In this video, I'm going to explain how we can do mediation analysis in R from scratch. Namely, we're going to write a function from scratch in R to do the mediation analysis. In this video, I'm going to cover a few topics. The first one is that I'm going to explain what bootstrapping is. The reason why I need to explain that is because we're going to use bootstrapping to calculate the confidence interval for the indirect effect. The second, I'm going to explain how we can write the R program from scratch to test the indirect effect. Third, I'm going to explain the standard error and standard deviation. The reason why I need to explain the differences and the connection is that we need to use the standard error to calculate the confidence interval. Lastly, I'm going to explain the bias in bootstrapping. The reason why I need to explain that is because the boot function in R will produce this output called bias. So I would like to explain to you what it is. We are going to also use the bias in the calculation of confidence interval. Bootstrapping is a non-parametric method based on resampling. So basic idea is that we got original data and we do resampling, and based on this resampled data we conduct analysis to calculate the indirect effect, and then we do it 5,000 times, and based on that we can test whether the indirect effect is significant or not. And how can we do that is that in R we can write a simple function to sample it and then calculate one indirect effect. And we can use the boot function to do it 5,000 times. And then we can calculate the confidence interval based on these 5,000 indirect effects. There are quite a few ways you can calculate the 95% confidence interval for the indirect effect. And here I'm going to discuss two of them. One is based on normal distribution assumption. So this is the first way to calculate the indirect effect. And the second one, we can just base on the percentile. So here we do not really assume that whether the distribution or the indirect effect is normal or not. We just based on the percentile. And so the lower bound is the 2.5% and the upper bound is 97.5% percentile. In the R Studio, I'm going to show you how we can do both of them. Now we got to the R Studio. Let me just recap briefly the method one. So the method one, basically we use the package called mediation, and so we include this package into the library and we use the function mediate. So here we just directly refer to this function to do our analysis, and then we got a result. And this is the indirect effect. So this method is pretty straightforward. And here I'm going to show you that how we can write a mediation analysis function from scratch. This is the core part of the function. So this is our method 2, that mediation analysis in R from scratch. Here, this is basically the mediation function I wrote. It's a function, and then this is the data set we're going to use, and this is sampling, to indicate the resampling. So here, this will be first one sample, and here we calculate the regression coefficient for the A pass, regression coefficient for the B pass, and then we calculate the indirect effect. So if you use this function once, you will return one indirect effect. And then we use the boot function to do it 5,000 times. So the boot function is that this is the mediation data. So this is the one we read the data we save here. Yes. So this is mediation data. This is the data we have saved, and then this is the function name, the mediation function, and we do it 5,000 times. So we can run this. We can run this session. So this is the output. So this is original. It means that it doesn't do any resampling. It basically uses all the data it has and then calculate the A and B, and then this is the indirect effect. If you watch my method 1 video, you will know that we also in that video also calculate the indirect effect. Based on all the data, we did not do any resampling. So that means that our function here basically is on the right track. Another one is the bias and the standard error. I'm going to explain that in a bit. The nice thing about these boost functions is that we say the result from the boost function as the book mediation, yes. And then we can just use the booked CI and then refer to the result we said, and then we can just like say that we would like to have the normal and the percentile, and that it will print out a complete interval. Let's run that. So as you can see, this is the normal distribution and this is the percentile. Remember that in the method one, you watched my video, the complete interval produced here is also based on percentile. And so the lower bound is 0.038 and the upper bound is 0.16. And you can see that this is a kind of very close. So that means that in terms of the percentile complete interval, we are kind of have consistent result. Another thing is that the nice thing about the result we save for the booked mediation, it also saves all these 5,000 indirect effect. Basically, we can plot the histogram to see the distribution. So we can use the plot, and this is the result we save from the book function. Yes, this is the result we save. So we can just like plot the result, so we can run that to see how it looks like. So this, we can see that the distribution is pretty normal. And we can also, you really want to print out all these 5,000, maybe there are a lot. So we're just going to print out the first 6 of them. So use the head function, print out all, the indirect effect. So we can run that. So this is the first 6 indirect effect. There are 5,000 of them since that we dig 5,000 times. Another thing, as mentioned, I would like to briefly explain the standard error and standard deviation in the context of bootstrapping. The definition of standard deviation is more straightforward, but what is standard error? Here is the standard error definition from the Wikipedia. So standard error actually is the standard deviation of a sample distribution. That means that if we would like to calculate the standard error for the indirect effect, we can basically just calculate the standard deviation of the 5,000 indirect effect. You might have question, why do we care about the standard error? Because if we would like to assume that the distribution of the indirect effect is normal and we want to calculate the complete interval in that way, then we need to use the standard error. So we know that in order to calculate the standard error, we can calculate the standard deviation. So basically we can just use the SD function to calculate standard deviation. And here I also again to print out the bootstrapping result again. So this is standard deviation of this 5,000 indirect effect. So here we kind of know that this should be also is the standard error or the indirect effect. So as you can see that, so I just print it again. We already print that earlier, but I print it out here again. So as you can see that this is standard error for the indirect effect. So this indirect effect, as mentioned, this is the indirect effect based on the full data. And this is standard error. As you can see that the standard error and the standard deviation of this 5,000 data point, they are the same number. So now you should have a better understanding regarding standard error, standard deviation in the context of bootstrapping. And if you have any question about this relationship or difference between them, you can comment down below and I will answer your question. But I guess my explanation is to be good enough, hopefully. Okay, another thing I want to briefly explain the bias. Remember here, we have a bias, yes, in the output. So what is the bias here? The bias is the differences between the mean of the bootstrapping estimate and the original sample estimate. Okay, so the mean of the bootstrapping estimate, we know that we have 5,000 estimate, yes, in that effect. So we can calculate the mean of them. And then we also have the original one, so namely this one. And the differences is the bias. So we can calculate the mean of this 5,000 data point. So this is the calculated mean. And then we can also, here basically we will again print out this number. So you can refer this as, this is T0. So you can refer to this one. We can print out this number again here. and then we can calculate the bias. Yes, so let's run this part. So this is the mean, and this is the original indirect effect based on the order data set without any resampling. As you can see, these two numbers actually are pretty close, but still there's a small differences, which is the bias. Okay, the question is that when do we need to use this bias? In order to calculate the normal distribution assumption, we can use the bias. We can add a minus the bias here to calculate the normal distribution confidence interval. The confidence interval based on the normal distribution assumption. Okay, so now we know that how we can calculate the 95% confidence interval based on the normal distribution assumption. Then we can write a function from scratch, and we're going to see that whether our output is the same as the one from this function, our book function. Remember earlier we mentioned that we can print out the confidence interval. Yes, earlier we print out confidence interval based on normal. Yes, but that's from the book CI. Yes, and then now we're going to write a function from scratch based on the formula we just saw. I just showed you on the slide, and this is basically, okay, we use this is the original one. Yes, this is the original one, this number minus the bias we define here, and then we minus plus times, and this is the SD of the order data, namely that's the standard error. Yes, remember that the SD of all these 5,000 data point is the standard error or the indirect effect. Now we're going to print again the normal from the book CI to see whether these two numbers are consistent. So we can run that. So this is the output that we write from scratch, the function. So this is 0.0377. So this is 0.0377, and this is 0.1570. So as you can see that they're exactly the same. So that means that, the function we write here from scratch is the correct. So hopefully I show you how we can write this function from scratch and then compare to the output from the book CI, and then we can see the same result. Now you should have a better understanding regarding the 95% confidence interval for the indirect effect. Okay, thank you for watching. If you have any questions, feel free to comment down below. And if you find this video useful, please like this video. Thank you for watching.